So in the mobile development space, discussions are often focused on who's winning the mobile technology wars. You know, how Android has the greater market share, how Apple has the greater revenue share, how BlackBerry and Windows are coming out with the next great products that's going to be a game changer. Not that a lot of us believe that. But for this session, the case studies are really important. They're going to be presented by my colleagues. And it's not really focused on who's winning, but instead really on what the factors were that led them to decisions about the technologies they chose and the mobile apps they developed, and specifically about what was right for their product. It's about identifying the right technology with the right benefits that offers the right capabilities for their end users. So in order to get us started, I thought I would take you through about a 15 to 20 minute primer. There's a range of folks in the audience here. We know we have a lot of new SSP attendees. And so for many in the audience, you may already know about some of these mobile technologies. And then for those in the room that don't, this is an opportunity to kind of set a level playing field before my colleagues go ahead and present on their topics, and you'll understand a bit more about why they chose the technologies they chose. So it's really not about who's winning, it's about what's the right technology for your product. So in talking about mobile technology, it's important to really separate the content layer from the display layer. And so we're going to focus today really on the display layer, not on the content layer. Pretty much all of these guys are working with content that is structured XML content underneath. It's not, I don't think any of the apps are really dealing with PDF as the primary format. We're dealing with display technologies, the native applications, and HTML5 or HTML presentations as well. So we're going to focus on that during the presentations. And so I thought we'd start with native apps, which is kind of where things all began for apps for mobile. So back in 2008, with the introduction of the Apple iTunes App Store, that was really the kind of start of things for mobile apps. Many other platforms followed suit with the Android Marketplace, later called Google Play, BlackBerry World, Samsung, Nokia, all of them kind of came in the game. But of course, today, as we all know it, the two primary players are really Apple and Android in terms of native mobile apps. And so there are lots of native mobile apps and a variety of types of products they deliver. A combination of feeds, a combination of content, very customized and very capable apps. So a range in our space. So really, we look at what's considered a native app and why they've been so successful today. Well, some of the key kind of attributes of a native app. It's a device-dependent, or more importantly, an operating system-dependent application. So it's built specifically for the operating system that it works on. So rather than using a dedicated browser to access content, the user instead interfaces with content that is loaded into a native application on the device. Content may be preloaded in the case of like a reference book or something like that, where the content is fully preloaded into the app when you initially download it from the App Store. Or content may be periodically downloaded, like your typical journal apps, that stream in new content as it becomes available issue by issue, or as published edit print articles become available. Besides stored content, additional content can be pulled into apps, streamed to the device via video and other content, pulled in from RSS feeds, accessed through what commonly is considered an in-app browser for native apps. So just yet another way to give the user the illusion that they're still in the app, but access content that's actually outside of the app. So as a result of these capabilities on a native app, a programmer can develop an app that performs a wide range of functions, many of which can take advantage of the processing power on the local device, and even take advantage of specific device capabilities like the camera, the accelerometer, or the GPS. So we've got offline caching content as well for native apps. For a long time, that has been really one of the primary features of a native app is its ability to cache content offline. You'll hear again from a couple of the colleagues here that that's really starting to come about in the web as well. But for a long time, the native app has really been the primary place for offline content. So additional content feeds, access to device capabilities, and those device capabilities can give apps further capabilities like scanning QR codes from within an app, using augmented reality from within an app. So these are all capabilities and features that a native app can drive because it's natively on the operating system and can access it on the device. That has typically not been the realm for an HTML app or a web app. So other attributes The custom features and performance. Performance has long been kind of seen as really a primary feature on native apps, the ability to customize and have faster performance, less downloading of content on the fly. But probably one of the biggest things, of course, is the large audience of users. Because Apple and Android dominate the marketplace in terms of operating systems, they also have the largest amount of users available to someone developing a mobile app. So the minute you develop a mobile app and release it onto one of the stores, you immediately have a really large potential audience. Now, if your app is not good, you're not going to have a lot of uptake. But if your app is good, you've got a wide audience to deliver to. So there's a lot of value in working with those very kind of well-known spaces. And specifically, the stores themselves are very clear and dedicated distribution channels. So when you're looking for an app and someone says, I want to know if this journal has an app, they're going to go to a store and they're going to look for the app there. They may not often go to the website. So this clear and kind of distinct distribution channel has always been a helpful thing for really kind of driving the uptake of mobile apps. So, not all users, though, are on those two primary platforms. So in many cases, the decision about choosing what platforms to develop for can limit the number of users in your audience. So if you're building for iOS or you're building for Android, then you're not building for Windows, you're not building for BlackBerry. But the reality is Apple and Android dominate about 95% of the market for mobile devices. And with that, you end up really making a kind of an easy risk-reward decision that says, I'm going to work on these two platforms and get the majority of the audience. And as you may talk to your colleagues or you know yourself, really most people will comment that the majority of their users are really coming on iOS for mobile devices. That isn't always the case, but certainly in the US, that's kind of the predominant case. So even though there is kind of a limiting of the audience, the other thing that can be a challenge with the native mobile apps is the submission and approval process. And as a company who's been involved in developing native apps for years, we've seen this as something that really has to be managed well. Because you're submitting through a store, you have to develop apps and push them through the store for approval. And while often at the initial outset a release of an app, that's something that can be managed in the project, when you have to deal with a critical bug fix or you're trying to get a release out before an annual meeting, the process still has to go through these paces of going through a submission and approval process. It can take as many as a few days up to a couple weeks to be approved on the iOS, where on Android it's much, much faster. But this can be a challenge to deal with. So native apps have that bit of a challenge. Folks often talk about the 30% revenue share associated with native apps and supplying them through the App Store. But the reality is, for most of us in the room, particularly in the journal space, the revenue share typically is not an issue. It's more of an inconvenience. Give away their app for free. Access to the full text content is available via authentication through a subscription, either individual or institutional. But this 30% revenue share rule extends beyond just charging for the app. There are things like you can't throw a pop-up to a user notifying that their subscription is about to expire and redirect them to the website where they can renew their subscription, because that redirect is essentially treated like an in-app purchase by Apple and Google, and they'll want their 30% cut of your subscription price because you're selling a digital product. So you can't even kind of put pop-ups in there. You have to be very careful about how you manage that. So these can be challenges with native apps. The walled garden, as people often refer to it, has both its advantages and in some cases some disadvantages as well. So the next topic I just want to touch on is mobile optimized websites. So this technology really has its roots in traditional HTML websites. And the layering on of things like cascading style sheets to provide design and formatting for the basic HTML markup, and then layering on things like JavaScript, which adds features and functionality to the presentation of content. So what exactly is a mobile website? Well, it's essentially a modified version of the cascading style sheets used to present a traditional website, but they're geared towards the presentation on a small form factor device, primarily your smartphones. In designing the display for the optimized site, elements are sized and laid out differently to accommodate the smaller form factor. Not all the features exist on mobile-optimized websites, so this has often been a challenge or an issue for users, is that there's something on the actual full site that isn't on the mobile-optimized site. So while they are helpful for an end user to come to the site via their smartphone, they also have a limited amount of access via that smartphone, because some of the features have essentially been chosen to be left off because there really isn't space for them. Other features, of course, can be modified to make them more usable for a touchscreen user on a smartphone, adjusting tap target size, etc. Of course, larger size tablets like the iPad and many others don't really need to utilize the mobile optimized site and are simply served the standard website. So when we talk about how mobile optimized websites work, we'll note the differences in the addresses above. For a long time, it often meant that when you went to a mobile optimized website, you would put in this case, I'll not use any journal sites because this isn't really a compliment, but the Domino's site here, if you go to the Domino's site, you're going to be immediately redirected. And so you're going to be redirected to a second site, basically, or a site that's using a different set of cascading style sheets, in this case, mobile.dominos.com. Other sites may have m. And so what that means from an end user's perspective is not a lot, but from the developer's perspective, from the owner of the site's perspective, you're now maintaining two different sets of code. So this is a challenge to deal with, having to deal with two sets of code in the site. So it's important to note that while a mobile optimized website is more appropriate for the small form factor device like a smartphone, the reality is that the result is the need to maintain those two distinctly different code sets. And so although they may use the same or similar HTML, they maintain two different sets of style sheets. Of course, the upside of the mobile optimized website is that all mobile users can get to your content regardless of what device they're on. So essentially they are operating system or device independent. So this is an advantage, of course, for mobile optimized websites. But they are, of course, limited. So importantly, and I think importantly leading into some of our other colleagues' presentations, web apps is kind of the follow-on technology that. It's the same idea of going to a mobile optimized website, but the design is geared very much to behave more like a native app. So you're not just going to a redesigned website, you're going to a website that actually looks, behaves, and in many ways performs like a native app. However, the oftentimes seen on many older sites, in some cases we don't see this as much anymore, you come to a site that is essentially a web app, presents, and you get a little pop-up at the bottom there that says, do you want to place an icon of this on your home screen? So the user can feel like this is an app truly on their device, but it's really nothing more than a shortcut that takes them to a website and gives them the feel that they're launching an app. And so they can end up with an icon on their desktop, like this L4M one over on the right-hand side. But there's a key difference between this app icon and the other app icons here. Note that there's no badging on it. And so push notifications, as they're referred, the little badge that tells me when there's new content available, native apps can perform that. A web app doesn't have the ability right now to deal with push notifications, so you're not going to get badged, you're not going to be told when new content is available. But otherwise, the experience when the user launches the app is it'll launch up just like an app. It'll go full screen mode, so you don't even see your URL bar, and you'll get the content loaded in and behave in many ways like an app. Now, this is kind of what I'll call a fairly early on web app. Some of my colleagues are going to present the web apps they've developed, or HTML5 apps, and they've really become much more sophisticated in time. But the one common thing for a lot of apps is the constant ability to access the internet and the need to access the internet and bring content down. So web apps have long been associated with having to constantly download content, constantly be connected to the internet. That is again changing as new technologies come about, and I'll touch on those in a moment. So, of course, you can't talk about web apps without talking about the Financial Times, which was one of the very first web apps that came out. They were essentially tired of the Apple model with their app and sharing the revenue with Apple for their subscriptions, and moved to one of the very first kind of well-known web apps. Gave the ability to, of course, bookmark and put it on your home screen, but they even gave the ability to cache content offline, which was pretty critical. It's a fully featured web app, and also, even lets the user know when the background content has been downloaded, so they can go offline now and read content. So this has changed over time for web apps. They've improved and gotten better as the technology has improved. And so, as I mentioned, several new technologies or updates to existing technologies are changing, and one of the biggest ones that everybody's probably heard of by now, of course, is HTML5. The other is CSS3, or Cascading Style Sheets 3. It's just iterations of an existing technology, but these technologies bring a lot of new capabilities. Among those features are the ability to cache content offline, as I mentioned, native support for scalable vector graphics, native support for MathML, the rendering of equations directly in the browser, no more converting them to images. Native support for multimedia content like video and audio directly being played within the browser without any need for a third-party plugin. This allows the apps to be a lot more lightweight and a lot more efficient in their process of handling content. In addition, HTML5 brings greater flexibility to the presentation, and some may say brings typography to the web. So we can do things in HTML5 with presentation that typically used to be the realm of desktop publishing. So you're going to see sites evolve more and more into their ability to display content in a much more creative fashion than the typical kind of single column approach of most HTML pages. So coupled with platform independence and the ability to manage the distribution of content without the dedicated sales channels, of course these apps really are just simply going to a website to kind of get the app. The web experience will continue to improve and level the playing field between native app capabilities and those of web apps. And so lastly, the other technology I'll touch on, again, to support some of the things that my colleagues will be presenting, is responsive web design. And there's been some talk at SSP in the last couple of days about responsive web design, and some of you may have gone to the session that was held yesterday. But for those of you that haven't, responsive web design is in many ways kind of a new technology. It's been around for a while, but new to a lot of folks. And as noted earlier, one of the challenges with developing a mobile optimized site or web app is that they require a different set of cascading style sheets or a different set of code to serve content to a mobile device. And in many cases, you end up with really only two very distinctly different sites, one for a full-size screen, one for a smartphone. And now, as we know, there are many. There's a plethora of mobile devices with varying screen sizes out there. And so responsive web design has been created to really address that problem. And so it works to address exactly that problem by using HTML, CSS, media queries, fluid grids. These are all things you can certainly look up. And using those properly, you can design a site that will dynamically change the presentation of content as the device size changes. Now, if you went to the session yesterday on responsive design, I can't help but speak to Toby's quote that he put up on screen from Bruce Lee that said, when you pour water in the cup, water becomes the cup. And it's just a great matchup with what it is, because the idea is the content should be fluid, should be able to flow into the presentation regardless of the size of the screen. And so really that's what responsive design serves to do. So here's several websites that are built with responsive web design. And so when you're at full screen and you're just really playing with these in a web browser, so if you bring up this Smashing Magazine site, as you shrink the size of the screen, the layout changes further and further until you get down to essentially a smartphone size. So there's a variety of sizes built within there, so the content is dynamically changing as the size of the screen changes. Now, of course, we're just in a browser simulating what it's like to maybe open the same presentation up on 4 or 5 different mobile devices, all of different screen sizes, but it can accommodate it well. So you're all the way down to a smartphone. So in this case, they've got multiple kind of grids built into this to reduce the size of the screen. And as it does that, the elements are changing shape, changing size, being rearranged. Some elements are dropping off, so not unlike traditional mobile optimized sites, you may lose some features. Others get nested, others change their orientation. The Boston Globe, another site that's been done as a responsive web design, doesn't have as many kind of grids in it, so there's not as much variation, but they've also set it up as well. And then lastly, kind of in our own industry, our very own JSTOR, which presented yesterday, also has built in a good fashion responsive web design as well, serving both their audience of traditional desktop users, tablet users, and mobile users for all the journals hosted on JSTOR. So these are continuing to be the technologies that are kind of driving the process of making mobile technology more approachable for end users. So with that, I'll wrap up. We'll move on with the show to the rest of the technology geeks on the panel, and